Good afternoon, everyone, or good morning, depending on your viewpoint. How has Tech Ed been this week? Good? Have they set the bar pretty high for me to beat or pretty low for me to go over? I hope it's been pretty high. I've seen the scores and they've been improving as we've gone on in the week. My name's Chad Zed Hauer, also known as kudzu. If you're interested in what kudzu is, it's a strange, funny plant in the bottom left of the screen. You can find out more at my website, kudzuworld.com. And today we're going to talk about a session called Dude, Where's My Business Logic? And I hope this is a topic that no one has discussed yet this week. I've been watching the different sessions, and I did another session on Wednesday this week, and I noticed two other people had a very similar session, just by pure accident. And I had to modify that one a little bit as we went. But this one seems to be a bit unique this week, so I hope you'll see lots of new and interesting material. I'm going to try and do a bit of polling as we go. I'll ask the audience questions, which is you, and don't be afraid to raise your hands or shout out or however you can give me some sort of feedback so I can get kind of an idea of what the audience is about. So my first couple of questions are, how many C# developers do we have? Quite a few. And VB? And .NET? Something else? Java? Okay. I want to thank the Java people for coming. The first step to recovery is, of course, admission. I also want to, I know there's a lot of people here that English is not your native language. So how many are native English speakers? Okay, and I'll assume everyone else is not. I'll try and speak as slowly and clearly as I can, but C# is my native language, so it's a second language for me as well. If you like what you see here, my two websites are in the bottom right. The bottom one, woohoo.net, is my professional website. The top one is where all of my blogs and articles and those sorts are. And I've written several articles on this topic and several ones that are related to this, and you can find them in the history of my blogs as well as upcoming articles that are very similar. Now, I used to work for Microsoft Corporation, as many of you know, and a lot of people think I still do, and it's very common for me after a session for people to blog on it, which is great. If you like the session, go blog about it. It's fantastic. Blog about what I said, spread the word. In fact, this session is very much an awareness, maybe even an evangelism type session. I'm going to propose some potentially new ideas to you here today that I hope we can convince the industry are very, very important. But people tend to blog that I work for Microsoft, which isn't a bad thing, and I used to, so I understand how it comes about. I don't anymore. I am a Microsoft regional director, though, and in this picture, they simply didn't let me in. They had minimum hair requirements in the 70s, which were quite high. This is a 300-level session in the spirit of the American Terror Alert System. I've hijacked it, so this session is coded blue on yellow, and I'm assuming that everyone in here is familiar with databases and SQL and those sorts of things. Over the years, we've moved from desktop to client server to 3-tier, finally to N-tier, and we just stopped saying the number of tiers because sometimes it's 3, sometimes it's 4. I've even seen 8 and 9 and 10-tier systems. And if you think you're only developing 3-tier systems now, if you're building a web application on a 3-tier system, you're probably already 4 tiers. Because if you think about it, the web server itself is a tier, which talks to the business layer, which talks to the database, and the web browser is the first tier. So you may already be going beyond 4 tiers. In the process of this evolution, many things have changed, but many habits have remained. And often this change, this resistance to the change is merely habitual. People did things a certain way, and we continue to do things that way in the future. Now, if anyone went to my session on Wednesday, I talked about a process called incrementalism, how we started out with a base process, and as we moved forward, instead of re-architecting things, restarting things, we slowly made changes. And the first couple changes were okay. If we started out, let's say, a 1.0 methodology, we said, this is how we build things, this is client server. And then we went to 2.0, it was probably okay, and 3.0. But at some point, when we got to our 6th or 7th reversion, things started to become a bit of a mess, and we need to go back and look at the beginning. And that's a bit what this session is about as well. Sometimes it's procedural, sometimes you want to make the change, but there are procedures and processes within your company that don't let you change. This session is going to talk about many things that we might be doing wrong. I'll leave it up to you to decide if you consider it right or wrong. and possible solutions if you agree with me that these are wrong. Now, what is a big system for you? Because I, several years ago, learned that what I define as a big system is different than what you may define as a big system. And I've spoken with quite a few of you at TechEd this week, and I've asked people, what's a big system? And they say, oh, 100 users, or maybe 1,000 users. For me, in the past, around 10 years ago, I was building systems that had to be deployed against the New York Stock Exchange and in some of the big trading houses, and we were talking millions and millions of transactions. So when I say big, I'm thinking very, very big. And possibly because of that, that's led me to design even what I would classify medium systems now to always be able to grow. Because the other thing to consider is that whatever you're working on today, you might say, I'm in some 5-man company and our biggest customer is 100 users. We don't need to think about these things. Well, the problem is startups often get bought out, often grow, often get a big contract. And one example that was given to me yesterday was, and I'm not allowed to reveal the name, but there was a major online betting site in Europe. And they built a system which they felt was reasonable and met all their expectations. And then the World Championship came to Germany. And all of a sudden, they were left in a position of having to re-architect their system under pressure to be able to handle capacity they never expected. So what I'm proposing to you is that a lot of the things I'm going to discuss today, you could very easily just dismiss these and say, we'll never have that sort of capacity. We'll never have this, we'll never have that. But I would like to say, but you never know. You don't know who's going to buy your company. You don't know who's going to buy your solution. You don't know who's going to integrate it. And one of the number one things, if not the number one thing I see when I'm going to enterprises is they are buying solutions from small companies. And their number one complaint is it doesn't scale. We have to throw massive amounts of hardware at this solution to make it work. And that's not really acceptable. We should be thinking about these things. In addition, we build these systems, and then many times we have to scale, and we realize we don't have time to do that, so hardware becomes the answer. These solutions, in addition, they have many benefits even if you never get to that point. They'll help you with your code, make it cleaner, and of course, make it scalable. What I present today is one way of building N-tier systems. As with many types of architecture, it is not the only way. If you want to design a skyscraper, a very tall office building, you can call in 5 architects, and they might come up with 5 different ways to do it. One might want to use steel, one might want to use concrete, one might want to use something else. There is no one way. What I'm going to give you today is based on my years of experience building, again, what I call big, what many people call huge systems. And I hope I can convince you of many of the parallels behind them. If you can't implement everything I'm going to show you today, I hope that you can take away at least one or hopefully more methodologies to think about when you're building your systems. I do have a warning, okay? Opinions contained within. Okay, there are going to be a few opinions here. And again, that's because this is based on my experience, but there are many ways to do things. So what are my objectives today? Well, ask any developer, if I were to ask any one of you today, where's your business logic? Well, everyone's going to go, that's a stupid question. The business logic is in the business layer. What kind of question is that? But I'm here, and one of the things I'm going to demonstrate to you today that even though you think your business logic is in the business layer, I'm going to show you areas that it's not. I'm going to show you areas where it's in the client and where it's in the server, even if you don't think it's there. Let's talk about a few quick terms, and the reason is that these terms are often bandied back and forth and often replicated and duplicated and used interchangeably between each other. So in the context of this session, when I say a tier, I mean a physical server or a group of servers. So if I say the middle tier, I mean the actual hardware that is running the software in the middle. If I say the client tier, it's the desktop or the web application. And of course, if I say the data tier or the storage tier, I mean the actual hardware the database is running on. Now, if I say layer, in this case, I mean the actual piece of software. And the actual piece of software can move back and forth. You can build a 3-layered system which you deploy across 3 tiers, and that would be the normal configuration. But you might take that same software, and so for some customers, they only want to buy 2 pieces of hardware, and they don't have a lot of customers. So you say, I'm going to put 2 layers on one tier and 1 layer on the other. So it's a virtual versus a physical distinction. First, I want to take you through evolution of a problem. How did we end up where we are today? We started out with desktop applications. Now, how many of you have been programming for more than 10 years? 15, 20, 25. Okay, there's still a few. So a few of you probably remember the day where desktop applications ruled, but I'm assuming everyone has built them at one point or another. And you can build a desktop application with a database. Now, today you're probably going to use a SQL database, even if it's local, whether it's Access or SQL Express or MySQL or whatever it is. But in the old days, we had things, Paradox and DBase and things long, long before that. But when you build a desktop application, you don't really have any motivation to separate any of the logic. So you just kind of put everything in one big executable, and you don't have any way to separate it out because you don't have a need. Some people might put it in an MVC, model view controller type paradigm, but I'm guessing most people don't when they're building a desktop application. So later on, these desktop applications evolve into client server. Now, client server is not so popular today, or so people think. There's actually a lot of client server development still being done today. Now, in the early days of client server, we had 2 distinct tiers. We had, of course, the desktops, and we had the hardware which ran the database, consisting of the application and storage. The first time we went to client server, though, all we did was we said, well, here's our database. We might have already been running against a local SQL database. We're just going to move the data. We'll keep all the SQL in the client and send it over. So we ended up with 100% of the business logic still in the client. We just moved the storage. The problems quickly became apparent. Back in the early 80s, and even late 80s and even early 90s, the networks weren't quite as fast as they were today. If you go into any enterprise today, you're going to find that on the desktop, they probably have at least 100 megabit. Back then, we had 10 or maybe even 4. Because back then, Ethernet wasn't even the most common network there. There was Ethernet. There was several different common proprietary ones. There was Token Ring. Did anyone have the joys of Token Ring? That was fun. Unplug one computer, the whole network goes dead. We also had high network usage. So we had low bandwidth, and we had something that was very chatty. It used to like to say, give me something from the database, and I want 40,000 rows back. And these sort of things created a lot of high network utilization. We also had the problem of application updates. How do we update the application every time it changes? So that led to a change in how we did client server. People started to say, if we start to put the business logic in the server, this will solve quite a few problems. It'll lower the network usage because we can do a lot more processing on the server. We can consolidate hardware. We can reduce the frequency with which we have to do updates. And in most cases, we ended up with something similar to this, where we had 35% in the client application and 65% of the business logic in the database. Now, all of the numbers I'm going to show here, they're just representative. Now, of course, they vary. I certainly have seen 20, 80, 80, 20, 50, 50, whatever you can imagine. But the point is the majority of the business logic in one way or the other ended up on the database. And this certainly solved a lot of problems. Moving the business logic to the server under those constraints certainly was a good choice. Putting it directly in the database wasn't, however, the best choice. But at the time, and some may even argue today, we didn't really have much of a choice in a client-server system. There were not good communication systems back then, so the natural place to put it was in stored procedures. And so it was a good, pragmatic choice at the time. Now, business logic in SQL. How many of you have ever thought about the fact that SQL is a domain-specific language? That's right. Now, DSL has become a real set of buzzwords lately. Everybody's throwing them around, and there were quite a few sessions here at TechEd this week on DSLs. And I think DSLs are a great implementation, and they allow people to do a lot of nice things. But few people realize that SQL was really one of the first DSLs. It's very good at specific things. It's very good at manipulating relational databases, retrieving results, and working with set theory. And of course, we made extensions, we added procedural extensions, and we ended up with things like PL SQL and T-SQL, so we had looping and if statements, and this allowed us to do a few more things. But how many of you think that SQL was designed to, say, take telephone numbers and properly format them? No one agrees, that's good. But how many of us are actually doing things like that or much more difficult things in SQL? Quite a few people, and quite a few more of you who are just afraid to raise your hands. I see it in many, many enterprises. And the reason for it was, again, back in those days, we had to get to the server. And what else could we implement them in? There wasn't really anything else available. And even when something like COM came along, I won't even touch that topic, but it was still better to keep it into the SQL. The net effect was, though, we did have an improvement, and it was a pragmatic choice. Longer term, we started to notice some of the problems here, though. First of all, we ended up with SQL monsters. I can go into just about any corporation which has a database that's older than a few years, and many that are brand new as well. And I can go to one of the DAs, and I can say, show me your monster. And he won't even have to think. He'll say, oh yes, stored procedure, blah, blah, blah. He knows exactly what it is. This is the stored procedure that is so large the printer runs out of paper. This is the stored procedure that impacts business functionality. This is the stored procedure that the business people come, they meet, they say, we want to do this. This will help our business compete against our competitors. And they come up with a plan, they come up with a budget, and they come to the developers. And the developers go, no, we can't do it because the monster is sleeping and we don't want to kick him. We don't want to touch him. Trust me, don't touch the monster. And explaining this to business people, they just don't quite understand. And usually the business people go back and say, okay, but how much will it cost? And the developers usually say, okay, $20 million, and then they go away. But in some cases, it's a really critical change and we have to make the change. So business decides we're going to make the change, and instantly everyone takes vacation. That's not a good position to be in. In fact, in most companies, I would bet there's more than one monster. Everyone just knows who the really bad monster is. And that's a situation we've kind of left. It's also very inefficient. T-SQL and many of the other procedural SQL languages are actually interpreted. The SQL statements are not interpreted. Those are pre-compiled. Those are pre-bound and often cached. But anytime you do looping or anything of those sorts, any conditionals, that's interpreted in most cases. String handling is usually completely unoptimized as well. So if you start doing anything other than saying, here's the data I want, spit it back, do some basic string manipulation around your where criteria and building your SQL statements, it's not the most efficient use of the language. You also end up with DBA disputes. Now, are there any DBAs in here? Okay, one. Can I pick on you? Are you a full-time DBA? Or just you've been shoved into that role? Okay, I'm assuming he's just kind of a shoved role. Actually, there are a lot of good DBAs out there. I have to say that because there's one in here, and that's a good DBA, okay? But as developers, we know there's a lot of DBAs that are not so friendly. Because what does the DBA care about? The DBA cares about, my database runs fast. My database doesn't crash. My database doesn't require a restore on a Saturday. They want a database that stays up. That's what they want. And most DBAs, they don't care a whole lot about what the end user sees because the end user is 6 or 7 layers away from them. Because it goes DBA, DA, developer, business analyst, user. And so their needs are very different than what the user or even the business people want. And unless someone really comes down on them. Now, in most corporations, you have a senior DBA or maybe one DBA, many DAs. And I'm not trying to pick on DBAs, but sometimes they become a bit territorial. Not always, there's some very good ones out there as well. The other problem we ended up with is we wrote all of this logic in procedural SQL. Now, standard SQL, when I do select, insert, update, most vendors are ANSI compliant. So there's, of course, there's ANSI 92 and there's different ANSI levels. So we can move that logic around. But what happens when we start dealing with ifs and loops and those sorts? We end up with vendor lock. And that's why many companies are still running on databases that 10 years ago were the leaders but aren't today, because they can't get out of them. We also ended up with some problems with cost. The cost of hardware on the back end is much, much more expensive. Now, everyone knows that the database has licensing issues. Every time you add a CPU, every time you add more capacity, there's a licensing cost involved. And DBAs are generally very expensive too. But the one that many people miss is hardware. They think, oh, memory's cheap, hard drives are cheap. Well, the problem is that hardware that goes on the back end, it's not the same hardware you put on the desktop. It's not even the same hardware you put in the middle tier. Usually, because it's a single point of failure, you need to put in redundant, hot swappable, very fast, very reliable hardware, and it costs several factors more than anything else in the enterprise. So when we went to 3-tier, we had several motivations for moving there. Well, first of all, the client-server systems, they grew because the companies were growing, and they often grew into thousands of database connections. And at least until about the mid, potentially late 90s, most databases, around 500 connections, started having a lot of problems. So people decided to go to 3-tier, and they did have several advantages by doing this. One was they were able to lower the connection count. They went to connection pooling. They said, okay, we have 5,000 users. But in any given second, I only have maybe 100 users requesting it, so I'll set up a connection pool of 100. And this was great from a licensing standpoint as well, until the database vendors found out what we were doing and modified their licenses. And this helped, but not fix everything. Then we evolved from there. And we had a middle tier. Sorry, we didn't, yes. Okay. We had the middle tier, and again, we had the connection pooling. And we also had some other advantages because now we could code in a language of our choice. We had languages such as C++, Visual Basic, Delphi, and even Java. And they were much more appropriate at building these sorts of systems. It did lower the connection counts, and again, until the database vendors caught on, it lowered licensing. We had the object-oriented languages. We still kept the network usage low. So many people like to say, well, we had a winner. It was a great system. We had some obstacles, though. We had DB kings. And this is, again, not to classify all DBAs this way, but many DBAs, they wanted to keep everything in their database. Once it got there, they didn't want to let it go. They wanted to make sure they controlled every SQL statement that went in the database. They said, dynamic SQL is bad. I will not allow it. All SQL must come through a stored procedure so I can see it, so I can control it. And there were some reasons for that, but a lot of this has changed today. On the dynamic SQL front, a lot of people in Oracle put things in views, and in SQL Server, they put them in stored procedures because they were pre-bound and pre-cached, pre-compiled, et cetera. However, most databases today have a query cache, and the difference between dynamic SQL and pre-bound SQL in many cases is very little, none, and sometimes it's even faster. We also had to overcome procedures within companies and often habits of developers. So let's move on to the next topic then. And what exactly is business logic? So I want you to think just for a second. You don't have to answer to me. Just think in your head. If you were to come up with maybe 3 or 4 sentences to define exactly what business logic is, what is it? Now I know most people kind of have an idea. They say, I know it when I see it. Well, the problem is, what you see and what you know is different than what your partner knows, and what everyone else on your team knows. So if everyone is looking at something and going, I know it when I see it, well, you have a lot of different interpretations of what business logic is. And that's how we end up with business logic in many different places. So business logic to many is just kind of a catch-all term, and it's definitely not widely agreed on. I've worked in a lot of companies, and not only does it differ from developer to developer, but it differs greatly between companies. Some companies are very, very strict. Other companies are very, very loose. Now, the database, I like to think of as a storage layer. And in the early days, the database essentially was only storage. But many of the databases, of course, have evolved since then, and we have business intelligence, and we have reporting, and we have many additional features on the databases, many of which are useful. However, I'd like to propose to you that some of the features the database vendors have added are not necessarily good features that you should be using, except to help you with existing systems. Now, I'm not saying all the new features. There are many new features you should definitely be using. But just because a database vendor adds a certain feature, don't think that it's a good feature you should be using in a new system. Some of those features they've added to make it easier to run and administrate existing systems which may not have been designed under today's tools and networks and options. Now, what I mean by a storage layer is that it's very good at storing data. Databases are designed at their core to store, retrieve, and modify. Now, many developers call this CRUD, create, replace, update, and delete, because those are the 4 types of SQL that we issue against the databases. And they're very, very good at this. It's all relational theory, and at the core, they're excellent at this. They're not very quick at implementing business logic, though. But many of us, again, another reason we put stuff in business logic is until the last few years, most of the reporting tools, how was the only way they could fetch data from the database? Through SQL. So if we wanted any sort of business logic in our reports, we had no other choice where to put it in SQL or build a data warehouse. Now today, many of the reporting tools, of course, can consume web services, XML, and many sorts of data sources. In recent years, this has actually been blurred a little bit as well with SQL CLR, and Oracle has an equivalent with Java, and I'm going to discuss these a little bit later. What I will say about SQL CLR is that it's not an excuse to say, okay, we're starting to move all of our business logic out of the database, but hey, SQL CLR, and I forget what Oracle calls their Java equivalent, let's move it back into the database. No, it's not an excuse for that. It does have some very valid purposes. One of them being if you have a system where you want to implement multiple layers, but right now you are small. You could use SQL CLR for many of those tasks because since it's C# or VB or any sort of .NET code, it's actually fairly easy to move to another tier later. But if you've written everything in PL/SQL or T-SQL, how are you going to move that to another tier later? Now, I have seen some nasty COM hacks, but that's exactly what they are. They're hacks. So at least if you're using SQL CLR or Oracle's Java equivalent, you have some sort of option to move. So I'd like to propose that the database is exactly storage. You treat it as store and fetch. Now, a very fast way of storing and fetching. Let's say that you have a customer object. Should the database have any knowledge of what the customer object is? How many of you think the database should have intimate knowledge of what the customer is? Okay. I think it should have intimate knowledge of what it needs to store a customer. It should know what the relations are. It should know what the foreign keys are and those sorts of things, referential integrity. But I agree with you that we shouldn't have other intimate knowledge about it. It shouldn't know the business rules. It shouldn't know things like, I can't delete a customer because he was a bad customer last month. It should know I can't delete a customer because there's still an entry in the billing table, things like that, but that's storage-related information. And let me give you some examples as we move forward. So I would like to propose here what I call database business logic flags. These are things that if you can answer yes to, that probably signify you probably have some database containing your business logic. Now, some of you probably know already. How many of you off the bat will just absolutely admit, yes, we have business logic in our database? Okay. Now, how many of you agree you want to keep it there? Okay, so most of you recognize that we probably need to move it somewhere. But in case you think you have all of it out, or just to give you an idea really what all encompasses business logic, let's go through a few questions. Does your database have any internalized knowledge of what a customer is? Now, not what needs to store it, but what is a customer from a business level? Do you have cascading deletes? Now, I've talked to a few people who think cascading deletes are a fantastic idea. We can have a debate about that a little bit later, and I can give you some examples why I think you should reconsider. But cascading deletes, especially when you get into the enterprise, have a lot of implications. Cascading deletes I'm going to propose to you is business logic. Triggers. Now, of course, every database is going to need at least a few triggers. But if you have gobs and gobs and hundreds of thousands of triggers, I don't think they're there for storage purposes. You're probably implementing some sort of business logic. You're implementing things like, oh, we deleted a customer. We need to notify the legal department to check so-and-so. Store procedures with obvious business logic. Now, I've already asked you that. Most of you raised your hands. Single store procedures modifying more than one table. Now, of course, there are exceptions to this, and this is not a hard and fast rule, but it's one of those things that if you have a store procedure that's updating 16 different tables, there's probably some business logic in there somewhere. In fact, probably significant amounts of it. The difference would be here is select. Now, of course, if you're selecting from 16 different tables, that doesn't automatically signify you have business logic because it's very common to join tables and retrieve. Good things in a database. These are things you should be doing even if your business logic is outside. Use stored procedures and views for optimized SQL. These are database-specific features. SQL Server, until around, I think it was SQL Server 2005, had specific reasons that you would want to put all of your SQL that was known ahead of time into a stored procedure. It could execute it a lot faster. Oracle was the opposite way. You wanted it in a view. And so many of us knew this about the different databases, and we put them in. The good news is, and not a lot of people realize this, but within the last, say, 4 and 5 years, almost every database vendor has realized that dynamic SQL is a valid business need, and we can't shove everything into stored procedures and views. So they have spent a lot of time building dynamic query caches, where they cache the plans, et cetera. It depends on your database, and it depends on the SQL, but in many cases, the gap in performance between the two of them is very little or none. Use referential integrity. Absolutely, please do not interpret what I'm saying as turn off referential integrity. If you turn off referential integrity, you will have a database full of garbage. If for no other reason that somebody who has access to the database who shouldn't will go in and insert stuff to fix things. Absolutely use referential integrity. Use constraints, keys, and indexes. That should be obvious enough. And of course, use null when appropriate. I have amazingly met quite a few people who believe null is evil for some reason or another. Let's take an example of delete customer. I'm just going to pick customer because everyone can imagine what's in a customer table, and many of you have these. This is a fairly simple case, but you can extrapolate what I'm going to show you here, obviously, into more extract cases. So let's take a customer. When you have to delete a customer, what might you have to do? Well, of course, I have to delete the record from the table, or maybe I don't delete the record, maybe I just mark it as deleted because I need to keep it for legal reasons. I need to check their billing table. Do they owe us money? If they owe us money, I can't delete them. And there's a variety of things that I need to do whenever a customer is quote, deleted. So these are the types of decisions. Can a customer be deleted? What procedures must occur? What safeguards must be checked? What audits must occur? Especially within the EU and the US, there are a lot of very specific rules around dealing with customer data. Not just from an auditing standpoint of your own company, but from a privacy standpoint. What tables might be affected? And what rows do I need to insert, delete, etc.? After I've mapped this out, I might end up with something that looks roughly like this. Now, of course, this is not anybody's dialect of T-SQL, but I think you can get the kind of idea here. This is an example of SP delete customer, where I select a row in a customer table. I see if the customer is locked. If true, then I throw some sort of exception because we're not allowed to delete any locked customers. Then I check the billing table. If they owe us money, then we don't want to delete the customer anyways, because that would be a great way to get out of paying your bill, is just call up and say, hey, I want to be deleted. If they're older than 1 year, then we need to survey them, so we're going to insert a row and delete the row in the customer table. Now, imagining that these are the comments for T-SQL or PL/SQL, how many of you think there's business logic in this stored procedure? Okay. How many of you think there's no business logic whatsoever here? Hey, quite agreeable audience. This is great. Either you guys are just agreeing with me, or you're all really, really intelligent people. I'll take for the latter. Now, how many of you have stored procedures that look something like this? Okay, good, we're honest too. Now, going to the business layer, we would be provided with several different types of gains. One is we would get rid of that database vendor lock. Now, some developers think it's really important to not be locked to a single vendor. Now, if you're an ISV shipping to big companies, then yes, it's very important because your customers typically come to you and say, we already have Oracle, we want to use it. We already have SQL Server, we want to use it. But in the enterprise, many companies are happy to be locked to a vendor. They say, look, we want to run one database, and we want it to run really, really well, and we're okay with using features to take performance gain. So that may or may not be important to you. Easier maintenance and debugging. Why? Well, for 2 reasons. Which is better, the T-SQL debugger or the C# debugger? The C# debugger? Or VB or whatever. Yeah. Everything's in one language. Because if I have it split between 2 places, well, sometimes I'm in the C#, and sometimes I'm in the T-SQL. And I'm going back and forth, and I end up tracing and debugging. It's much easier if everything is in one place and in one language. And also, future business logic can't slip into the stored procedures as easily. If I have this big stored procedure, and I have just 2 little items of business logic. If that stored procedure even exists, it provides an entry point for future business logic. The next time we have to add a feature, the EU says, every time you delete a customer, you need to audit that and keep them in a table, a separate table for 2 years. Someone says, hey, there's a stored procedure that does that, and it's hooked to a trigger, let's go add it. If you don't have the stored procedure to do it in the first place, they'll at least have to think about where they want to put it. And if there's C# code to do it, they're likely to follow the path of least resistance and go to the C# code. What about formatting? Is formatting business logic? Well, sometimes. Maybe yes, maybe no. I'm going to propose it's actually sometimes it is and sometimes it isn't. Because think about something like money. Well, how do you format money? Because the euro symbol goes after the numbers. The dollar symbol goes before. But then some people put commas and some people put decimals. Some currencies have 4 decimals after the digits, some have 2. There's all kinds of rules you really don't think about. And I know here in Europe, we deal with all kinds of stuff that has a dollar sign on it when it's really euros, because somebody didn't really think about it. So it's a mixture. Always, I would propose that telephones and postcodes are always business logic. Not certainly open for debate, but I'm going to use a telephone example as we go through this in a few more slides. I know you'll see more there. I would say things like time is probably never business logic, because that's relative to the user's machine. If I have the time is the same in Europe as it is in the US as it is in China. But they display it in different ways. If I'm going to display the time here in Europe, I'm more likely to display it in a 24-hour format. Whereas in the US, I'm more likely to display it in a 12-hour format. And the same thing for the dates. Here in Europe, I'm going to put the day, then the month, not the month, then the day. So you should probably allow the client machine to format that sort of information. Don't confuse formatting with verification. They're not always the same. So business logic or not, how would we decide? Does the format vary with the contents? If I want to format a telephone number, there is no one way, say, here's a telephone number, here's how to format it. Here's where the parentheses go. I have a real life bug up here. Hold on. Okay. How do we format it? I can't just say the parentheses always go at the 4th and 5th character. Because it depends on what? The country code. And even within a certain country, there are several rules for how I format a telephone number. So it does vary with the contents. I need to inspect the contents. Does the format vary with dependent data? For instance, the postcode. If I have the postal code, the formatting of the postal code depends on what country it is. But the country is stored in a different field. So if I have a postcode here in Spain, I believe there are 5 numbers. In the US, they're 5 or 9. In Canada, they're 6 letters or numbers. So it's very much dependent on the country how I format that. Does the format change frequently? Now postcodes, their formats don't change very often. The US did change theirs around, 20 years ago. They went from 5 to an optional 9. But telephones are something that changes fairly frequently. Why? A lot of new mobile phones, fax machines, all sorts of different things. I spend half of my year in Russia and half of the year in Cyprus. And in Cyprus, we've changed the telephone numbers twice in the past 10 years. Why? Because there's so many people coming from other parts of Europe to enjoy the beaches who pick up SIM cards. And we simply ran out of phone numbers. Because back then, no one planned. They said, well, Cyprus population is not going to grow. They didn't plan for mobile phones. And you always have to take into account these different formatting rules that they're going to change. Is the format well defined and fixed? Well, the format for money, date, and time is probably not going to fix. I mean, it's not going to change. It's fairly well fixed. We could agree on that. It's been the same for 20, 100, who knows how long. Is the format localized? Things like date and time should probably stay in the client because every client's going to have a different conception of how it should be displayed. And I know here in Europe, it's a really big problem. When we see a date and we see 1/5, is that January 5th or May 1st? We have to think about it. Well, who's the vendor of the software? Now, if it says something like 1/30, we can be pretty sure it's January 30th. But we have a problem the first 12 days of every month. So sometimes I have to go in and put in a date and see which one it'll reject before I know which way the software is accepting it. And it's even more fun when I go to a website, which is using my regional setting to detect my mask, but the business layer only accepts US formats. So now I can't even make a reservation unless it's in the first 12 days of some month. And there are a lot of websites that do that. They think, oh, we'll be regional, we'll include the Europeans, but we won't fix our business logic, mostly with web applications. Let's take a look at telephones. Here are some example telephones for Cyprus, Germany, North America, except for Mexico, I believe they have a different one, and Russia. Within each country, these are all the same telephone number. So you can see in Cyprus, I have 3 sets of formats. They're all the same telephone number. And the reason for this is there is no official way to write a Cypriot telephone number. So of course, we have the country code, and that could even be 003, it could even be 00 or a plus or nothing. And then sometimes they put the region code in parentheses, and then you have the local numbers. But sometimes they put dashes, sometimes they group them by 3, sometimes they group them by 2s, and sometimes I even see strange things where there's 4 and 4. And Germany is fairly standard because, well, it's really efficient and precise there. But the biggest reason is they actually have a regulation called DIN 5008, which specifies how German phone numbers should be written. So that one's pretty easy. The USA, Canada, and Caribbean, they're pretty standard. The first one is the more common one, but sometimes you see the second one. So you have, of course, the country. The unique thing there is they actually share the country code. And I see this mistake in a lot of business logic. They think, oh, 357 is Cyprus, 49 is Germany, 44 is the UK, 1 is the US. There's a problem there. 1 is also Canada and many islands in the Caribbean. They share the 1 code. This is also the source of a lot of telephone scams. You need to be careful about that. Russia is 7, and you can see that you have varying ways to represent the telephones. So let's take back with the first slide we had before that with the considerations. The input, there's a variety of formats. Every country has at least one. They're all very, very different. The UK and Germany are different, and they're different from Spain yet. Each country has unique formats. Some country formats are not very simple. Some are very straightforward, some aren't. The region codes, some are variable in length. Now in Cyprus, it's very easy. I know that after the country code, the next 2 digits are the region. I can look at it. Cyprus is the big place. We only have like 5 cities, so I can memorize them all. I know 25 is Limassol, and 22, and 23, and 24, etc. I know that anything that starts with a 9 is a mobile. I know 99 is one provider, 96 is a different provider, etc. But you can't do that in many countries. And I know they're 2 digits. But then take a country like Russia, where they have a lot of region codes, and they're not even the same amount of digits. St. Petersburg is 812. But Siberi is 3 plus 3. So you end up with things like 3952. So sometimes the region code is 4, sometimes it's 3. And I know in many European countries, sometimes you have that 2 versus 3 versus 4 for mobiles, etc. And the country codes are variable length. That's really important to understand. You can see that even the example I had, you have +1, then you have things like 44 and 49, and then you have things like 357. These are the types of things that are not necessarily easy to handle in T-SQL. So let's take the procedure for actually formatting a telephone number. Now let's say that I've adopted the first format here for, I'm going to say plus the country code, and then I'm going to say, okay, it's Cyprus, so I'll go 2, 3 digits, 3 digits. First thing I'm going to do is whatever format the user brings it in, I'm probably going to do very little validation on it. I'm going to check to see, is there a plus or a 00? If so, I'm going to knock them off and say, hey, there's a country code coming. Then I'm going to strip everything else out, and I'm just going to check the length, which again is variable in some countries. But in Cyprus, I'm going to say, okay, after the country code, it's 8 characters, so it's okay. I'm going to strip everything out, so I get just a series of digits. Then I'm probably going to split it into 2 things, the country code and the local telephone number. Now I might store it in the database as 2 fields once I got that. And then I'm going to have to process the country-specific code. Now the procedure for this, if you don't have an object-oriented language, is very, 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 very big. You end up with something like SP process telephone number, which has a huge case statement that says things like SP format Greece, SP format Germany, and this never-ending stored procedure. If you do something in C# or VB, it's obviously much easier. Now, formatting it in client, many people decide to put the code there. It's often duplicated, though, because they have to put this code in the client and the backend. This requires a large amount of data on the client because you can't even tell how big the country code is to find out what country it is without pulling down some sort of country table. And then you have all the region props, et cetera. And of course, it requires frequent updates. If you look at just a single country, how often they update the formats of their telephone numbers, then multiply that by the 180 or maybe 200 countries in the world. I don't know how many there are. There's a lot. There's a lot of changes. And how well do you keep up on the telephone changes in Papua New Guinea Anyone? Probably nobody. We might know when there's a telephone code change in Germany, but there's a lot of countries out there. So you might decide, let's format them in a stored procedure. Well, as I said, SQL's not well suited for this. You're going to end up with not just one monster, but probably a whole bunch of ugly monsters that no one wants to maintain. You end up with a complex system and an awful lot of bugs. You end up with German telephone numbers that get formatted as UK ones because somebody made a bug and they didn't check it very well. SQL CLR would be the one case that this might be a good chance. But then again, SQL CLR sometimes makes it too easy to put your business logic on the database. But if you're working on a small, or in my case, what I would classify as a medium database, you're okay, with the provision that you can easily move that to a physical third tier later. Sometimes you end up with double storage, and I see this one very commonly. People will store the phone number unformatted so we can index it, and then formatted so we can display it. The problem with that is what happens when the formats change? Well, I have to run through my whole database and reformat all the telephone numbers, and that's when I find all the bugs in my software again. Stored as is. And this one's ludicrous. You might say, why did he even put this slide up there? No one is ever going to store it how the user, just let them type in anything they want for a telephone number, put a plus, don't put a plus, put a dash, type in letters, whatever they want, and just store it. Does anyone do that? Quite a few people. How do you look up someone's telephone number with a reverse lookup? A little bit difficult, huh? How do you determine someone's country? A little bit difficult. I see that quite commonly. In one company I worked at, the company owned lots of railway cars because they did a lot of shipping, so they just bought their own cars for the railway, and the railway came right to their factory. And railway cars have a unique ID. It's a railway GUID. It's like a license tag for the rail car, except you don't see it. That's how they identify them, when they've been serviced, when they crashed, and whatever happens to the history of the railway car. And we had a system back then from a really large ERP vendor that didn't handle railway cars. So they decided to extend it. But the system didn't allow validation, so the basic idea was they could put it in any format they wanted. And we had railway cars with dashes and slashes and spaces and dots, and the company could never figure out what happened to each railway car because there was no way to go backwards on the information. So telephones, maybe it is UI. Well, I don't think so, because it depends highly on the business logic. You need to be dependent on other fields. It's dependent on fields, on the field itself. As business logic, you eliminate the duplicate data, you have centralized logic, and of course you reduce the updates, in addition to the fact that it has data it depends on. So let's switch now, talk today about today's tiers. Client server is alive and well. Who's building a client server application of any sort? Okay, quite a few people. Those of you that didn't raise your hands, you're probably surprised by how many people did. It's still there, and it's not going to go away overnight. And for small applications, it often works. Now, this is typical, as I showed you before, to have 35% in the client tier and 65% in the database. Your numbers, again, are going to vary. And many N-tier systems start out as a client server, and we move to a multi-tier system from there. And you have opposing forces for putting your business logic in places. Because I can say, well, I want to put it in the server because it changes a lot. I want to put it in the server because the database guy can do the SQL. But I want to put it in the client because it's easy to write. And so when you make a decision where to put your business logic, you don't really make it on where should I really put it as a developer or an architect. You put it on easy or frequently updated. And they're kind of opposing forces. So let's go multi-tier. We're all set. We're going to build a multi-tier system now. We're beyond client server. You would think that, hey, great, now I'm going to put all my business logic in the business layer, sometimes what we call the middle tier. But unfortunately, we often end up with more fragmentation than we did in client server, because now we have 3 places to put things instead of 2. Think about it. When it's a desktop application, we knew where it went. There was one place to put it, that's where everything went. We never put it in the wrong place. We had 2 places. We wanted easy to write or easy to update. And from an architectural standpoint, think, oh, 1, 2, 3, this one's called business tier, business logic, hey, I'll put it here. But not everyone on your team, not everyone in your company thinks that. They think, ooh, there's 3 places. I'll just pick one of the 3. It's like a lottery every time. I'll put this one here, this one here, and this one here. And then you have really fun debugging these sorts of things. And you end up with 3 sets of code, because now you have a formatted routine in the back formatting the telephone number, and one in the middle, and one in the client. And sometimes they even conflict, and you get these round-trip bugs, because the You validated it on the client, you submitted it to the database, but the database threw it back. Let's take scenario 1. I see this very frequently. This is really, really common in systems that were formerly client-server. What happens is they put a business layer in the middle, a business tier, with 0% business logic. So you say, what the heck does it do if there's no business logic there? What they've added is they've added a physical, but not a logical. So we've ended up with 3 tiers, but 2 layers. And it does have some use. You might think it's totally useless. It's not, because you have to think about network topology. In here, you could be taking SQL connections and returning them as XML results or as a web service. You could be doing connection pooling. So there are some valid uses to this, but it's not really a business layer. What you end up with instead is more of a transport layer. Again, perfectly valid, but it's not really what we would think of as a 3-tier architected system. More commonly, you end up with something like this. You end up with, say, 15% in the client application and 60% in the back end because there's so many stored procedures, no one wants to really rewrite them. And since no one wants to really rewrite them, all the new business features still going into them as well. So that's a danger. As long as you don't rewrite those things, they're going to grow unless you have some sort of policy. And maybe 25% in the middle. And yes, it is an improvement. At least we can start to implement a lot of the things in C# or VB or whatever the language is of our choice. But again, now we have the problem of we have code in 3 places. And sometimes we have the same code in 3 places, and debugging becomes quite interesting to say the least. We end up with a duplication. So if we have different types of clients, maybe we have a desktop application, and maybe we have a PDA application, and maybe we have a web application. Whatever percentage of the business logic that ends up in the client, we then have to duplicate among these different clients and maintain it as well. Now, if they're all running .NET plus, say, Compact Framework, et cetera, it's certainly easier, but you still have the problem of updates. Now you need to update all of them as well. And then as soon as somebody comes in and says, I have a legacy VB6 application or a Java application, then you're in quite a bit of trouble. And of course, one more thing on this slide is that if you don't duplicate it between the client application and the business layer, you can see here, these ones add up to 100%. But that's not really valid. They should add up to around 115%, because that 15% that exists in the client, you also need to make sure is in the middle tier, because the client runs on the user desktop. And if someone decides they want to hack in and change their salary, if you put that business logic, cannot change salary in the client, and that guy gets smart enough to run a web spy, HTTP spy, and figures out the web service call, guess what he's going to do? Bypass the client and raise his salary, or take all your corporate data. So you need to duplicate that. Now, what I call the sky goal. This is, if I could have it however I wanted it with no other considerations, this is what I would have. I'd have 100% in the middle and have 0% on the other sides. But I realize that it's not typically possible. But this is the goal, nonetheless, that you should be moving towards, even if you can't completely achieve it. Okay? It's like my optimum weight. I would love to be 60 kilograms, but I can't quite seem to get there. Doesn't mean I don't keep shooting, a little bit lower, but. So we have maintenance and debug, one location, one language, and DSLs are possible. We can actually make our own DSLs for business. And what's really nice about these is before anyone even heard of DSLs, some of us, myself included, we were writing something very similar to DSLs. We were working with systems analysts who could come in and we could say, here is the business logic. Why don't you verify that this matches what you know about the database in our business? Now, back then, they were never going to read C++ or Delphi code, but we wrote it in such a way that they could at least verify it and write the basics of it. So if you have it in middle tier, you could even think about writing a DSL around your business that if you're working with systems analysts or business analysts, they could work on. It's fast, efficient, lower consumption of the database because you're moving processing out of the database. Practical goal, and again, these numbers are absolutely going to vary. But in the systems I've built, which are fairly typical except that they're very big, this is fairly possible to put 99% in the middle, 3% on the client, and about 1% in the database. Now you notice again that 99 plus 3 plus 1 doesn't equal 100. That's because the 3% in the client application is also duplicated in the business layer for security reasons. And the 1% in the database, these are things that absolutely have to go in the database because they'll kill the network. These are things like mass updates, batch updates, and those sorts of things. So there is an exception, you'll never get there, but this is a bit more pragmatic. Minimizing your client business logic, how can you do that? Because you're going to say, I need to do things like format a telephone number. Well, there are many, many options today. In fact, many more options have even come about in the last 1 and 2 years. So if you're still thinking about technologies even 2 years ago, even 1 year ago, you really need to reassess the situation, especially on the .NET platform. So much has changed. You say, I'm going to format a telephone number. I want to do it in the client. Why? Why don't you call the server? Even if you're building a web application, you have AJAX. If you're building a desktop application, even if that desktop application is connected over a 28.8 modem. Now, how many of you ever use a modem today that connects on less than 28.8 because you're traveling? How many of you go to Africa? How many of you go to farther parts of the Middle East? Siberia. So I'm the only one that's still connecting on 14.4 modems. It happens. Even on a 14.4 modem, you can make a small compressed web service call to say, here's the telephone number the user typed in. Can you please format it for me so I can show it? Now, if I'm the only one running on an analog modem, I'm sure the rest of you on DSL or fiber or cable or satellite or whatever it is you have can deal with that. And I'm guessing almost all of your applications are that way. The one difference would be, of course, disconnected applications. If you have PDAs or salespeople who don't have connections, then that's a different thing to think about. But I'm talking mostly about generally connected clients. Updatable clients. Well, this is something else. This is if you have to put some of the business logic in, of course, you want to make it updatable. Well, of course, Silverlight. If anyone's been to Silverlight talks, that's something that's generally auto-updating because it gets pulled down like a web page. XPaps, any sort of web application. I'm going to take Click Once out of this because Click Once with the WinForms application, it's more like a standard install. It automates it, but you still have kind of a big install every time. Or metadata. Think about regular expressions. What about implementing a scripting language? There are plenty of scripting languages out there that run under .NET. Couldn't you decide that, hey, my telephone number formatting routine, I'm going to write in some sort of scripting language so that when my client connects, I want him to run it because he's going to be disconnected. I will fetch the script which runs to format the telephone number. That's one way. Metadata. You can't do it for everything, but you can certainly take things like input fields and say, well, this field should be 5 characters long. I think everyone here can figure out how to get that information off of the server. Yet we don't. We hard code that in the client applications. And mobile agents, which is one of the sections I talked about actually last year at TechEd. And this is the ability for code to move around. And the idea here is that they execute on the client, but they don't exist on the client. If you want to know more about that, you can check the archives of my blog. Moving to the middle. There's a slippery slope here, again, to put everything in stored procedures because, well, there's already tons of business logic there anyways. If I have 60% of my stuff in the business logic, and I was a developer who didn't know better, I'd say, hey, well, 60% of it's there. That must be where they want it. Let's just put more of it there. The database assistant will do it. I'll hand it the DBA, the DA, I won't even have to do it. He'll stick it in. This should really be the exception, not the rule. In fact, I would recommend you put in a defined acceptance procedure. You say, if you want to create a new stored procedure, you have to pass it by the architectural committee and justify why it should go in the database and not the business layer. Don't just say, you know, guys, don't do it very often, but if you want to, go ahead. Because developers, they follow rules how well? They're going to follow whichever rule might get them home earlier on a Friday. So if you make a rule that has to at least go through some sort of review, then you can decide whether or not they should be stored procedures. It's easier. More is less. More hardware is cheaper. The reason being is the type of hardware. Now, the type of hardware you're going to put in the middle tier is more expensive than what you put on the desktop, but it is a lot cheaper than what you put in the database. Because in the middle tier, you're going to put many different racks. You're going to put rack servers, you may put storage, access networks, etc. You're going to have some redundancy, but the redundancy is on the server level, per server or per drive. When you implement it in the database, you generally have one big machine with a lot of processors. And if the memory fails, the whole machine goes down, the whole company goes down. So you need more expensive memory. You need hot swap cards. So it's cheaper, even if you need more hardware. If you say, I need 2 business layer processors instead of adding 1 processor to the database, you know what? Buying 4 middle tier racks will probably be cheaper than adding 1 more processor to your database. That's where you should go, even if it's more hardware. Because in database, again, you have hardware, you have licensing, and the biggest thing here is it's a single point of failure. You also have limits on how big your database can go. You can take the number of middle tier servers and go virtually to infinity. Look at how Google is going. How many servers do they have? Now, if you have to grow your database, most of your databases have a well-defined limit, and the bigger you get, the more expensive the hardware gets. Putting in a 4-processor box, that's pretty easy. I can get 4 processors, 4 cores. I can even go to 8. Once you get past 8 processors, the hardware changes significantly. And again, when you hit 16 and 32. Plug and play, you just add another rack server, put it in the cluster and go. If you want to upgrade the database, well, you have to start thinking about partitioning, replication. There's all sorts of things to think about. Let's take a look at the topology here. Now, you can see by color here, they're telling which server they're going to, and they're load balanced across them. But at the business layer, they always go to the same database. Okay? At the bottom, we can see that as we move towards the database, towards the right, the cost per unit increases. The average bandwidth per unit also increases as well, because those yellow lines there, if your system, if you're dealing with a lot of traffic, that's probably gigabit or faster fiber on the back end. You probably have a dedicated switch. Your database is connected to this dedicated switch and directly to the business layers. And that switch is not connected to even the same network as the clients. It's a dedicated network that only connects those. And with fiber and gigabit, you know what? That's pretty darn fast. You can run stuff on those middle tier pieces about as fast as you can on the database in most cases. But from the business layer down to the clients, you're going to have all kinds of varying speeds. It's probably 100 megabit, 10 megabit, modems, GPRS, UMTS, and it's okay, because again, you're going to have slower bandwidth there. But realize that you have really fast bandwidth on the back end, or you can if you want. But the maximum number of units almost changes as well. Where the clients are, I may have 100, 500, 1,000, 10,000 of them. But how many databases will I ever have? Well, I might have 2 if I partition them, but it's still really 1 database in the end. I end up with 1 piece of hardware unless I start significantly altering my database and re-architecting portions, which has its own set of negative problems. Let's chart them relatively. Now again, I've just picked general numbers. These certainly could vary depending on your hardware and network configurations, etc. But the maximum number of units goes down while everything else goes up. Bigger database, big iron, big money. Licensing, the whole bit. So if you have 20% in the middle tier and 80% on the database, well, what do you think is running all the business logic? It's not going to get processor out of the sky. It's going to take processor from the database queries. So you're going to have to prematurely upgrade your database to run your extra SQL business logic. Worse yet, as I said before, T-SQL and PL/SQL, they're not optimized for the type of processing you're probably doing. So not only are you consuming processing use off the database server, but you're consuming it inefficiently. If you move that to the middle tier, even if you didn't improve the efficiency, you would lower the cost. But you're also going to improve the efficiency, and therefore you'll really lower the cost. Stored procedures are not generally movable. If you want to move logic out of T-SQL or PL/SQL, you have to rewrite it or do some kind of nasty hack to move it to another server. If it's in SQL CLR, again, you can move it out. So again, SQL CLRs are very viable options for small to medium businesses because you can't just take it and move it instantly, but it's fairly easy to move. More in the middle. Everyone's heard the term server farms, right? No one's heard of a server farm. Few people. Well, server farm is the middle tier. It's where you put tons and tons of servers in. You walk into a room and they're all stacked up. Think of server farms as in rabbits. Let them grow like crazy. You know what, if you walk and say, hey, we need 10 more servers, no problem, put in 10 more. But if you go to the DBA and say, we need 10 more processors, he's going to go, uh-oh, we need to think about our quarterly earnings because we need to buy really expensive hardware. We need to think about partitioning, and we partition, we're going to have to think about how that's going to affect all our clients. And then we need to think about changing our storage area network and blah, 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 blah. It's not an expensive or even transparent change. But how many people have ever heard of a database farm? No, because we usually have one big central database or we have a partition of databases. The maximum number of units goes to 1. We can't grow it. beyond a certain point. We can put more processors, we can put more memory, we can put more disks, but at some point, we're going to really hit the limits of hardware, and that's when we start re-architecting our databases and affecting all of our clients. Everything in the end funnels down towards the database. And this is one of the primary reasons, besides the fact that it's easier to write, that we need to move stuff towards the middle tier. Obstacles. Well, one is habits. You've heard the saying that old habits die hard. Developer habits die harder. Once developers learn something, I mean, how long did it take us to get rid of the go-to statement? Now, hopefully none of you are still, is anybody still using go-to? Okay, one person. At least he's honest. 1.5 people. It took us a long time to get rid of the go-to statement. Why? Everyone was used to using it. It's just like Link. I think Link is fantastic. I can't wait for Link to actually, now that they announced RTM, Link is pretty much released as soon as we can get our hands on the release later this month. But it's going to take developers a while to realize, hey, that would be better done with Link. Hey, that'd be better done with Link. On the other hand, some developers are going to try and use Link for everything, and we're not going to be able to read anything because we're going to have, simple things that were this big. So you need to be careful as well. But you need to realize when to change new habits. Team habits are self-preserving. Let's say you all leave tech ed this week, and you go back and you say, hey, you know what? We're going to start to move our business logic to the middle layer. Everyone says, yeah, it kind of sounds good. But most of your team says, no, we've always done it in stored procedures. Well, now you're one person on your team trying to convince the rest. And developers don't like to stick out to management, right? Because management controls what? Our pay. So we don't want to be the noisy guy in the team. So we might just kind of sit back and say, well, here's what I learned. So you have to go back, and you have to convince the rest of your team, and you have to convince management. Because if it's just 1 or 2 of you on a team of 10 or 20, they're going to outvote you. You need to convince them why. And it's kind of like herd behavior, though. If you scare one, you can kind of get everybody moving. You also have problems with procedures. Many companies have written policies that say, put it in a stored procedure. But no one has looked to see that that document was written in 1991. Now, 1991 in computer terms, in other industries, that's like, what, 1200 BC? That's a long time ago. We should be evaluating any policy that's older than 2 or 3 years without a doubt. I'm not saying throw it out, but I'm saying at least give it a look and realize it's old. Now, the other reason is .NET. It's gotten a lot easier in the .NET world in the last year or two. Before then, it was quite difficult. There were a lot of reasons that, yeah, we all knew we wanted the middle tier, and there were ways, but maybe it was a little more work than we wanted to do, so we just kept thinking, well, we'll wait a little bit while. Fortunately, the tools have caught up or are very close to catching up. Security policies sometimes get in the way as well. We have WCF, code access security, and identity. Because a lot of times your security policy says all security must come from the database. So that's part of the reason you get there. But if you can sell your management, explain to your DBA that, yes, hey, what? We have code access security now. We have things called identity. We have things called card space. We have LDAP. We have all of these things. And show the enterprise guys, you know what? You couldn't manage it 5 years ago very well. You couldn't manage our code. We could get around you anytime we wanted. But if you can show them now that they can manage the security policy on the middle tier, that'll be your biggest selling point to getting the security out of the database. You'll still have security in the database, but my point is it doesn't have to be the only point to implement security. And of course, awareness. Database administrators, touchy topic. I kind of started on that one a little bit before. DBAs are probably 50-50. You either have a good DBA or you don't. Maybe you have a middle line one, but in my experience, there's either good ones or you don't have a good one. And you either have one that wants to work with you and really listens to your needs and says, hey guys, you know what? If there's something I can do, let me know. If you want to change something that I did, bring it up and let's talk about it. Other DBAs, all they care about is going home on Friday and not coming in on Saturday. And one of the things with DBAs is they don't change jobs as often as developers do. Because in most companies, that DBA is like the king position. He's worked 10, 15 years to get to that job. And he may not want to move around, and in some cases, he may still be thinking 20 years ago. I was in one company that had a DBA that thought ARC302 were great primary keys. Does anyone think that's a good idea? We didn't either. We couldn't even change customer names. So when one customer got bought up by another customer, nope, sorry, we still got to call you by the old one or make you a new customer because you're a ARC302 you're a primary key. Not to mention our database didn't run real fast. Fortunately, most DBAs are not that bad, but some of them are very territorial. So you need to decide, do you have a database president or you have a database lord? If you got a president, you can probably work with him. You can go to him and say, here's what I want to do, here's why. You guys can have a chat. If he's one of the other ones, you might need to go to management. If it ain't broke, we don't fix it. That's kind of an objection to the database guys, because a lot of them, they don't see the problem. You have to make your case to them why we want to move to the middle tier. Give control to developers? What are you, crazy? These are the guys that are always breaking the database. Why would I want to let them have control? Well, I don't know how to get around this one, but you got to talk to your DBA. Clean and fast, nothing else matters. I don't do Saturdays. Explain to your DBAs that actually, if anything, this will lighten the load on their database, it will reduce the bugs, and it'll make their database more easy to maintain. Why? You are going to them. Don't say to them, I want to take control of your stored procedures. They're going to go, but if you go to them and say, you know what? I want to reduce the amount of code in your database. Isn't it all in how you sell it to them? If you say, I want to reduce the amount of code in your database, he's going to go, hey, that's kind of cool. Let's talk. In fact, you want a beer? You have to sell it to them, and that's what you're really proposing, is you're saying, let me take some of the stuff out of the database so you have less to manage, because you're an overworked DBA. You work so hard. I want you to focus on backing up and not debugging stored procedures. I'm thinking about you. What tools do we have? Well, again, until the last year or two, the tools we had, they're really good at connection pooling. That was no problem. They were good at doing things like disconnected clients, where I could come in and get some data. Maybe I stay connected, maybe I don't, and I send it back, and we do the updates later. They were reasonable at doing database independence. With a little bit of work, you could work with multiple databases. They were poor at isolationism. I'm not going to cover what this is today, but one of the articles I have that's related to this one, and I'll have in a later slide, is called Tier Pressure and Isolationism, which I talk about how we develop between the different tiers. It was poor at very large scalability. Now, it was certainly scalable in most people's terms, but when you started to get really, really big, the tools we had, they didn't scale very well. And business logic implementation, they were horrible. How many of you use data sets? Okay. How do you put data into a data set? Use the fill statement, right? Hey, it works great so long as you can write the SQL. You can have the data any way you want it, so long as SQL can do it. And the minute you want to change it, there are ways to change it. You can write some custom ways in data sets. But most developers don't know how to do it, and it's not the most efficient of ways. And that was one of the reasons we limited ourselves to what SQL could do. What solutions do we have? Well, one is architectural reviews. You should be regularly checking code, especially stored procedures. See what's going in. The sooner you catch something, the sooner you can fix it before it goes out. Educate your DAs. Now, I'm not saying your database assistants are not uneducated. I should change a slide. Forget DA education. Let's call it DA evangelism. Let's go to them and show them how we want to help them out and make their jobs easier. Explain to them what you want to do. Just don't go over and say, hey, I want to change everything that works, because that's what they'll hear otherwise. Tell them, you guys can still control the SQL. I'm not going to trash your database. But you know what? I do want to submit some dynamic SQL. So why don't you set up a process monitor, and you can watch the kinds of things that I'm coming over during development. And then once you've seen everything I'm going to send over, you know in production it's not going to change. Let them set up stored procedures that have specific SQL with parameters, but just say, look, I want to move the business logic out. Or let them set up views. Come to some sort of compromise here, but at least start to get some, if not all, of your business logic out. But tell them, I'll still let you control the SQL. No problem. You can be assured I'm not going to send over SQL that's going to take the database to its knees. Really, it's less work for them. Management, again, let's call this evangelism, not education. They're easier to convince, but depending on your DBA, you might get some backlash. So think about what type of DBA you have first, if he's a president or a lord, and you might want to ping him first before you go to management. What kind of frameworks do we have available? Well, first one was custom business objects, which many people do. And certainly, if you're using custom business objects, it's not bad, okay? I'm not here to say anyone who's built their own framework is a bad thing. It actually can be a very good thing. But in my experience, most of the ones I see, they're not truly successful. That doesn't mean they all aren't, but just a lot of them aren't. But until the last year or two, in some ways, they were kind of nearly necessary for many of the things you wanted to do. SQL CLR helps a lot, but again, remember that SQL CLR is not a final endpoint. But with SQL CLR is, at least if you get your logic into SQL CLR, it's still in the database. But if 90% of your customers are on small databases, hey, let it run there. but make it in a way, since it's C# or VB, you can easily move it to another tier, which you can't do with the other ones when you get big. At least you have some sort of escape route there. There are a lot of performance and memory considerations. So before anyone does any serious SQL CLR, make sure you watch one of the recorded sessions from TechEd this week, or maybe there's one or two good books. The one I know is by Bob Boschman. You might check that. He talks all about SQL CLR and what's good and what's bad and how to be careful. Just make sure you know what you're doing before you get into heavy SQL CLR. .NET datasets. Now, many people have been using these because they've been around since pretty much the beginning. Now, there were some drawbacks, especially anyone using .NET 1.1. There were some serious performance issues that didn't increase linearly, but more exponentially when we dealt with large amounts of data. Those were fixed in 2.0. These were the best prior option. So if you're using datasets, that's not a bad thing. In many cases, you could do quite well here. Just realize, don't limit yourself to SQL. Realize that if I get into a situation that I need to fetch something that I can't do with straight SQL, that there are ways to customize the datasets and expand them with the business logic. ADO.NET for entities. Did anyone go to the ADO.NET sessions this week? Did anyone see the entity sessions? What did you guys think of it? It's pretty cool stuff. When Microsoft first announced this, I think it was maybe even up to 2 years ago, they used to call it EDM, Entity Data Model. And the first time I saw this, I thought, that's it. That's what we've been waiting for. And they've changed it quite a bit since then, in many good ways. And this is something that's really exciting. If you haven't looked at ADO.NET for entities and you're building enterprise applications, you really, really need to take a look at it, okay? If you're using data sets and you're realizing, you know, I wish I could do this, I wish I could do that, I wish one was flexible, look at ADO.NET for entities. And of course, it's capable with LINQ, both LINQ on the entities and LINQ to SQL on the back end if you're using SQL Server. So it's really an amazing option. The only problem is it can't ship soon enough. We're still waiting for it, which is okay. I want the guys to do a good job. I'm not complaining. I'm just saying, hey, I wish I had this 10 years ago. And I'm really excited it's coming. The good news is that there's CTPs coming soon. And from what I've heard, it's generally baked. There's not going to be a lot of changes, but we need some testing, and I hope it'll ship. I don't know what they said at TechEd this week, but I'm pretty confident we'll see it before the half of next year at the latest. Get familiar with it now. There's no reason to wait and say, hey, you know it's going to come out, I don't know, 7 months from now. Let's wait till then. Get familiar with it now. When the CTPs come out, start building some stuff again and just realize you can't deploy it till it ships. In fact, if I was going to do a new system, if it was at all realistic, I would even postpone it. I realize most of you can't do that, but if it's possible, I would if it's a really big system. Let's go to the conclusion quickly. Remember that stored procedures are the exception, not the rule. In fact, it's even right there. Exception, not the rule. Formalized review, acceptance, and modification procedure. Examples like massive batch updates. These are things that should still be kept in stored procedures. Isolate, keep your business logic very unique and in the middle layer, and implement only what's necessary in the stored procedure. Now, everyone always has tons of questions, and the clock's at 0. Don't worry, I have 2 more slides. So I can't answer questions all up here, and I know everyone has different questions. What do I do if you this? But what about this case? This won't work in that case, and blah, blah, blah. Everyone has a reason why what I said doesn't work. It does. Just go home, think about it. If you want, drop a comment on my blog. There are ways around this. I had 1 hour to explain to you how to design enterprise systems with middle-tier business logic. This is easily something that could be made into many, many days. So just because I didn't explain certain situations, every little situation, doesn't mean it's invalid or there's no way to do it. Summary, changing directions, political, often risky. Take what you can. I doubt everyone's going to go home and to their office and implement everything I said today. But I hope at least you can take one, hopefully many more pieces of this, at least into your thought process as you develop and modify and expand your systems. Better, a little better, but a little better is, at least a little bit is better than none. It's really best with new systems, but you can of course apply it to existing systems as well. Further reading, you can go to a website called Code Project, which is really easy, www.codeproject.com. Select the search, change it to author, it defaults to article, just put in my last name. You'll see maybe a dozen articles are there. There's 2. There's one called Dude, Where's My Business Logic? I wrote it around, I think, 3 years ago. Most of it, almost all of it's valid. There have been, okay, well, it's all valid, but almost all of it is still valid under today's conceptions, but some things have changed a little bit with new tools and frameworks. I've updated this deck around that. But almost all of it just applies today. You can read through it and you'll find most of what I said here today. In addition, there's another one called tier pressure and isolationism, which talks more about how we develop. How do we make sure it stays in the business layer? Why do we end up with things over here? How do we end up with interdependent dependencies, et cetera? And there's other goodies. And of course, my blog at kudzuworld.com. I want to remind everyone before we go to fill out the evaluation forms, because I know everyone likes to leave and go home, and I'm between you and probably some beer. But before you get to the beer, fill out the evaluation forms, or maybe after the beer, as long as you still have wireless access, because then maybe I get a better mark after the beer, I'm not quite sure. But just please fill out the evaluation forms, okay? I'm done. That's the end. I hope you enjoyed it.